So the last part of 8.1, we're just going to kind of go through some more examples. I want to make sure you guys see all the different things that you might see on your homework and beyond. So, according to the American Community Survey, a 95% confidence interval for the median household income in Texas during the years 2009 to 2011 is, whoa, what is that? That is a different way to write an interval. The point estimate comes first, plus or minus the margin of error. So we literally have right here the point estimate plus or minus the margin of error. So that is going to make these questions pretty easy. First of all, I'm going to answer the last part of part A. The part A says, what is the point estimator and what is the point estimate? Well, the point estimate is literally that first number right there. It would be the middle of your interval if you had it in interval notation. So this would be 58,929. Now, what is the point estimator? So I've been telling you guys that it could be either mean, proportion, standard deviation, and then I throw you this curveball. The point estimator here is the sample mean. It is the sample median. Sorry, sample median. I said mean, didn't I? Sample median. That is the point estimator here. So it's just basically what are you using to estimate the truth? And we're using a sample median to estimate the true median. What is the margin of error? This should be a pretty easy one. It's, literally just the $218. 218. That's it. There's a margin of error. Man, this seems easy now, doesn't it? All right. The next thing we need to do, guys, is we're actually going to write the interval in interval notation. So what is the actual confidence interval? So we're going to take that point estimate and we're going to subtract the margin of error in order to get the low estimate. And then we'll take that point estimate, we'll add the margin of error to get that upper estimate. So take your 58,929, subtract the 218, and you should get 58,711. That's your low estimate for the true median household income. And then take that 58,929 and add the 218, and you should get 59 something or other. I don't remember what it is. 147? And there's your interval. Cool? Oh my gosh, guys, we get to interpret. You know what that means? We get to write a sentence. A golden sentence. Yay. We are 95% confident that the interval from 58,711 to 59,147 captures the true median household income in Texas in 2009 to 2011. Questions about that one? All right, we got 10 minutes to finish. Let's go.
Wait, I'm not doing.
Oh my. We're going to go real fast. Are you ready? I'm not going to ask any more questions. I'm just going to write the answers. No, I'm kidding. All right. So, many teens have posted profiles on sites such as Facebook. Dun, dun, dun. A sample survey asked random samples of teens with online profiles if they had included false information in their profiles. Y'all wouldn't do that, would you? Of 170 younger teens, aged 12 to 14, polled, 117 said yes, they had included false information, you guys. Of the 317 older teens polled, 152 said yes. A 95% confidence interval for the difference in the population proportion. Younger teens minus older teens. Now that's going to be very important, the order that is the subtraction is happening. So younger teens minus older teens. The difference in the proportion of the lying, younger teens minus older teens, is 0.12 to 0.297. What that means, guys, is that there is a 12% to 29.7% difference in the proportion of teens that lie, younger versus older. So what is the point estimator? P hat. P hat estimates proportions. P hat estimates true proportions. Now, the only thing here is that we're looking at a P hat difference. So I would have P hat, and then in the little subscript, I would just write diff. This is just to help me remember that I'm looking at a difference between two proportions. So technically here, guys, just so you know what you're looking at P hat for younger minus P hat for older. That's technically what you're looking at here. We can simplify that by saying P hat of the difference. Now, the point estimate, it's still located where? Right in the middle of the interval. The point estimate is still right in the middle of the interval. So, the estimated difference in the proportion is the middle of the interval, which is? Did you say 2? You were partially there. 0.2085. Super close. And what is the margin of error? Now, the margin of error is the distance from the middle out to the sides. So, what is the distance from 0.2085 out to either one of those? I don't care which one. Alrighty, it's very good. 0.0885. Nice. It's exactly what it is. Good job, Scott. All right. Any questions about that? Fantastic.
Really smart.
Scott is the smartest in the room. All right. Now, you guys are going to start seeing questions like this very often. Does this confidence interval give convincing evidence of a difference in the population proportions of younger and older teens that include false information in their profiles? Okay, again, here's what we did. We took the younger teens' proportion of lying, and we subtracted the older teens' proportion of lying. Now, if the younger teens lie at the same rate as the older teens, then what would I get when I subtract their proportion of lying? I would get a 0, right? If they were lying the same amount, I should get a 0. So if young and old teens lie the same, then 0 would be in the interval of values. Remember, that interval is what you think the actual truth could be. And if they were actually lying the same, then 0 should be in my interval. Was 0 in the interval? It was not. So, since 0's not in my interval, I have convincing evidence that there is a difference in the rates of the lying. Since 0 is not in the interval, we have convincing evidence of a difference. Now, not only do we have convincing evidence of a difference, guys, but we can even tell who's lying more. All of the values in the interval are positive. It's a positive 12% to a positive, 19.7%? Something like that? So all of the numbers are positive. If I'm taking younger minus older, and I'm getting a positive proportion every single time, who's lying more? Those younger teens, little liars. Man. So since all values are positive, younger teens are lying more. Sad. Anybody have an idea of why that might be? They do want to be cool. You used to be a younger teen, you know. Also, there's an age restriction on Facebook. So in order to get on Facebook, you have to say you're at least 13. So there you go. All right, cool. I'm telling ya, watch out for them. All right, let's talk about Cody and let's talk about brushing your teeth. Do you guys brush your teeth? Why? Nobody can see them. Oh, hygiene? Okay, got it. As part of a project about response bias, Cody surveyed a random sample of 40 students from his school. Both of Cody's parents are dentists, so many of his survey questions had to do with brushing teeth. One of the questions required students to state aloud whether or not they brush their teeth twice a day. Based on the responses, Cody said that he was 90% confident that the interval from 0.79 to 0.96 captures the true proportion of all students at the school who brush their teeth twice a day. What would happen to the width of the interval if the confidence level were increased to 99%? Would the interval get wider, narrower, or stay the same? Wider? Yes. When you increase your confidence level, the interval gets wider. Think about that Garfield cartoon about the weather. The dude was never wrong when the interval was super wide. When you guys were guessing how many blocks were in this bucket with a huge interval, a huge margin of error, you were pretty confident you got it right. But as the interval gets smaller, your confidence gets smaller. So the same thing happens, but in reverse. As the confidence level goes up, you're getting more confident because you have more options of capturing the truth. You have more of a width of actual, whatever I'm trying to say. You know what I'm trying to say. You have more options to be right. That's what I'm trying to say. Okay. What about if I have my 90% confidence interval, so back to the original, explain what would happen if I increase the sample size to 100. What's going to happen to the interval? Will it get wider, narrower, or stay the same?
Wider, 60 more students.
I see the logic there, but that's not quite right. So when you increase your sample size, you decrease your variability. Do you guys agree with that? Okay. Well, guess what? Margin of error is the variability of your interval. So if you increase your sample size, you decrease your margin of error, which tells how wide the interval is supposed to be. That's the plus or minus. So, margin of error is the variability. So, increase sample size, interval decreases. You can also think of it this way. If you increase your sample size, you're getting a better representation and you're getting a more accurate prediction. All right, the last question is a trick question, so I'm just going to go ahead and tell you that up front. Describe one potential source of bias in Cody's survey, that's supposed to say survey, that is not accounted for by the margin of error. Margin of error only accounts for sampling variability, not any bias. So the fact that he asked these questions out loud, the margin of error does nothing for that. The figure below shows the results of taking 25 simple random samples from a normal population and constructing a confidence interval for each sample. So look, here I've got an X bar, margin of error, an X bar, margin of error, an X bar, margin of error. You with me? Yep. All right, cool. Here is the true population value right here. Which confidence level do you think we should use? So remember this, confidence level is the percent of many intervals that captured the true parameter. So what Kaylee's noticing here is that they all go through the parameter. So there's not, but 100% wasn't an option. So 99. Okay. So we're going to go with 99%. Because the very next interval could miss the truth. This is just a snapshot of 25 of the many intervals that we would do. So this is just a small selection. The very next one could miss it. Okay? So why are we going to settle for 95 or 90 or 95, you guys? Why not be 100% confident?
Because sometimes it's not going to be there.
You never know what the future holds.
Oh my gosh.
You guys, about a year ago, you thought you were going on spring break and then you were coming back to school. You did not.
Yeah, it was the longest summer ever.
It was. So, you never know what has happened for all of eternity, right? Guys, we have always come back after spring break, and then we didn't.
Well, we did come back online eventually.
Did we though?
No. Technically, yeah. There were no classes.
So, you never know what the future holds.
We abolished school.
You need to give a chance for being wrong. You cannot be 100% confident of anything. Because I promise you guys, the moment that you say you're 100% confident of something, someone will prove you wrong. Every time.
So you're only 99% sure that we won't have school on
Oh, I'm 100%. All right.
Meteorologist say so.
Therefore, we will be coming to school on Wednesday.
All right, you guys. So, what is the risk of being incorrect that is associated with your confidence intervals? So, confidence level versus the risk of being wrong. Yes. Yes. The risk of being wrong. I can spell. All right, guys, if I am a 99% confidence, what is my risk that I'm wrong? If I am 95% confident, what is my risk I'm wrong? If I am 90% confident, what's my risk I'm wrong? If I am 27% confident,
73.
what is my risk I am wrong? You guys see how that works? There you go.
I know basic math.